Hello and welcome to MyScience Tutorials. In today's video, we are going to be talking about the introduction to differentiation. Before we begin, if you are new around here, make sure you subscribe to our channel and press that notification button so that you will be informed when we upload a new video on biology, chemistry, mathematics, and physics. So let's begin. So how do we differentiate a function? So assuming we have a function of the form y is equal to what? X raised to the power n, and we want to differentiate this function where n is what? It's a real number, either a positive or negative integer or even a fraction. There is a way we go that will help us to differentiate this. So by differentiating this, we add what? D to the y to make it the differentiation of what? Y. And because we are differentiating with respect to x, it becomes what? Dy dx. Now, once we apply dy dx to this function, it means we are differentiating the function y with respect to what? X. And then this is how it goes. We use the power over here to multiply the coefficient what? Of x, and then we subtract 1 from the power. By that, it becomes what? The power now comes down. We have n multiplied by what? X raised to the power n minus 1. So we use the power to multiply the coefficient of x, and then we subtract 1 from the power, and that becomes what? Our differentiation of the function above. So let's look at an example. Assuming we have the example y equals what? X raised to the power 4, and we are to differentiate this function. It means we need to apply the differentiation sign, that becomes what? Dy, and we are differentiating with respect to x, so dy dx is equal to, now the power is 4, so the 4 now multiplies the coefficient of x, so that becomes 4. The coefficient of x is 1, so it's still 4. Then x raised to the power what? 4, then we subtract 1 from it. So it means our dy dx becomes what? 4x cubed as the differentiation of the function x raised to the power 4. Alright, so let's have a look at another function. Assuming we have the function of the form y is equal to c, where c is a constant. It's a constant. If we differentiate this function, our dy dx becomes what? 0. So it means if we differentiate a function that is a constant, we get 0, or the derivative of any constant is 0. So let's have a look at an example. So assuming we have the example y is equal to 4, and we are to differentiate this function, because we are differentiating with respect to x, it means the equation y is equal to 4 here has what? X raised to the power 0. And because we know x raised to the power 0 is 1, or any number raised to the power 0 is 1, it means this is what? X power 0 is 1, and therefore 4 multiplied by 1 is still 4. So that is how come we have the equation y is equal to 4. So with this, we can now go ahead and differentiate. So our dy dx becomes what? We use the 0 to multiply the 4, then we subtract 1 from it. So we have 0 multiplied by 4, x power 0 minus 1. Then our dy dx becomes what? Because this is 0 multiplying this over here, okay? Any number multiplied by 0 is what? Is 0. So it means if we differentiate a constant, we get what? 0. So let's have a look at another scenario. So assuming we have the function y is equal to what? Ax, where what? A is a constant. Now if we have this, okay, it means if we differentiate this function, our dy dx becomes what? Just what? A over here. Okay, so how is that so? Because the function over here, the x has the power what? 1. If we differentiate this, let me do that one by one so that you can see. So we have our y is equal to what? Ax. If we differentiate this, our dy dx becomes what? The power over here is 1, so 1 multiplied by a, so we get 1 multiplied by a power x raised to the power 1 minus what? 1. So we have our dy dx becoming what? 1 multiplied by a is still a, x raised to the power 0. And we know x raised to the power 0 is what? 1. So finally, our dy dx is equal to what? The constant a. So let's look at what? An example of this. So if we have the example y is equal to negative 7, y is equal to what? Negative 7 x, and we have to find what? The differentiation, or we have to differentiate this function. How do we go about that? So first of all, if we differentiate this function, we get what? Our dy dx to be equal to what? Because the x over here has the power 1, we use that 1 to multiply the negative 7. So we have positive 1 multiplied by negative 7. Then the x comes here, power 1 minus 1. So we have our dy dx becoming 1 multiplied by negative 7 is negative 7. Then we have our x raised to the power 0. And then we know what? Our dy dx becomes what? Negative 7. Any number raised to the power 0 is 1. So we have 1 here. So finally, our dy dx is equal to what? Negative 7. Alright. So let's continue. Now, we want to have another scenario. So assuming we have the function or function of the form y is equal to what? The function f of x plus the function g of x, then minus the function h of x. Okay, how do we differentiate this function? Okay, so if we differentiate the function y, it means we are applying what? Dy dx to this, which is equal to what? D dx of the entire function over here, that is what? F of x plus g of x minus what? H of x. Okay, now when we are differentiating individual functions that are what? That are put together by addition or what? Subtraction sign, we can differentiate the individual functions one by one, and then we add all of them together to get the overall differentiation of the function. By this I mean what? Our dy dx now becomes what? D dx of the function what? Of the function what? F of x, then plus g dx, that is the differentiation of this particular function g of what? X alone, then minus the differentiation of what? The function, the third function, that is what? H of what? X. So it means once we differentiate each of the functions individually, we can now add all of them to get our overall differentiation of the function. So let's look at an example. So assuming we have the example y is equal to what? X raised to the power 5 plus 1 minus x minus 4x, and we have to find what? Find dy dx of the function, which means we have to differentiate this function. How do we what? Solve this function? So first of all, if we differentiate this function, let me rewrite this function in a form that we can simply what? Differentiate. So we have y to be equal to x power 5 plus 1 over x becomes what? X inverse, or x raised to the power negative 1. Then we have minus 4x over here. So from here we can easily differentiate the function. So our dy over dx becomes what? D dx of the function what? X power 5 plus x inverse minus 4x. Okay, so from here we have what? Our dy dx to be equal to what? The differentiation of each of the individual functions in the bracket, that is x power 5 plus d dx of the function x inverse minus d dx of what? 4x. This is 4x because the negative is already outside. So it means our dy dx becomes, now we can differentiate this function individually. Okay, so now if we differentiate x raised to the power 5, it means we use the power 5 to multiply the coefficient, which is 1, then we subtract 1 from the power. So we have what? 5 multiplied by what? X power 5 minus 1, then plus, then this function. So this, we have negative 1 as the power, so we have negative 1, we multiply this, then x power 1, then we subtract 1 from the power again, then minus, this is 4x, the x has the power 1, so we use 1 to multiply the 4, then x raised to the power what? 1 minus 1. Alright, so it means our dy dx of this function becomes what? 5x power 4 over here, then this becomes minus what? X raised to the power negative 2, then we have what? Minus 4x raised to the power 0 over here. So from here we know our dy dx becomes what? 5x power 4 minus what? S negative squared, then minus what? 4. From here we can rewrite this in a more beautiful way, that is 5 power 4 x power 4 minus what? 1 over what? S squared minus 4. So this is the answer that we obtain after we differentiate the function what? X power 5 plus 1 over x minus 4x. Alright, so let's have a look at another example. So we have to differentiate the function y is equal to what? 4x cubed minus 3s squared plus what? 5 on what? S squared. Alright, so let's look at the solution for this example. Solution. So let me rewrite the entire function in a more suitable way. So we have y is equal to 4s cubed minus 3s squared plus 5x negative squared. Okay, so we brought the s squared over here to the top. So if we differentiate this function, it means we are applying the y dx, that is what? D dx of the entire function that we have over here, that is 4x cubed minus 3s squared plus 5x negative squared. So it means our dy dx becomes the differentiation of all the individual functions we have in the bracket. So we have d dx of the function 4x cubed minus d dx of what? 3s squared, then plus d dx of what? 5s negative squared. So our dy dx becomes, now if you like, because 4 is a constant, you can bring it outside or in front of the d dx, then you just differentiate what? S cubed, and then you use it to multiply, and then you continue, or you can continue ahead. Okay, so for the sake of this tutorial, let me bring the constants that are just the numbers outside. So this becomes 4 d dx of the function what? S cubed, then minus what? The 3 will also come outside, 3 d dx of what? S squared, then plus, I bring the 5 outside. Oh, let me erase that. Alright, so 5 outside, d dx of the function x negative squared. So from here, let me continue here. Our dy dx becomes what? We now have this 4 over here. We still have it over here. Then we differentiate this function. Now if we differentiate what? S cubed, it becomes what? The 3 comes and multiply the x. So we have 3x raised to the power 3 minus 1. Then we have minus the 3 that we have over here. We still have that one here. And then into bracket, if we differentiate what? S squared, we get what? The 2 comes and multiply the s squared. Then we subtract 1 from the power. So this becomes what? 2x raised to the power 2 minus 1. Then plus the initial 5 that we have over here. I'm writing it here. Then we have what? This becomes what? Negative 2 multiplied. This becomes negative 2x, negative 2 minus 1. So let me rewrite all of this so that you can see it very well. So I'm rewriting everything over here. So we have 4 into bracket 3s. Let me simplify this. This becomes squared, then minus 3 into bracket 2x. This becomes just 1. Then plus 5 into bracket negative 2x. This becomes what? Negative 3 over here. So from here we can just simply do the multiplication, and then we get our answer. So we get 4 multiplied by 3, we get 12s squared, then minus 6x. Then this becomes what? Minus 5 multiplied by negative 2 becomes negative 10 x raised to the power negative 3. So from here we can simply just what? Rewrite this equation in a nicer way, and then we get our solution. So our dy dx becomes what? 12x squared minus 6x minus 10 on x raised to the power what? Cube. Okay, so this becomes our solution, our differentiation after we differentiate the function what 4x cubed minus 3x squared plus 5 on what s squared. So thank you so much for watching, and I will see you in the next video. Bye bye.